All right, we're on lesson 4 of Unit 6, and today we're going to be working with solving rational equations. So we've been graphing a lot lately, so first we're going to try solve by graphing. So if we have this equation 4x squared over x squared plus 5, and that's equal to x plus 3 over x minus 1, one of the ways we could solve it is to treat each of these sides of the equation as if it was its own function. And we've done this earlier in the year with some radical graphs and maybe some polynomials, I don't remember. So we'll treat our first function as if it's 4x squared over x squared plus 5, and then the other equation is going to be x plus 3 over x minus 1. Now you can go ahead and put each of those into your calculator as a y1 and y2, and then when you graph it, it should look something like this. So it's graphing both of those functions. So that first one is this equation, or sorry, this function. And then the second one has these two parts, right here and right here. So our original equation has those two things equal to each other, and we've talked before about that what we're looking for then as our solution is that point of intersection. So on your calculator, to find the exact value of that intersection point, you're going to use the second button, and you're going to use the calculate function, which is above the trace button. Don't use the trace, please. It is not very exact. And you're going to choose that fifth choice, which is intersect. Now, when you do that, it's going to ask you a couple of questions. It's going to ask you what's the first curve, and that should be this one on the graph. And it should just have that equation displayed at the top of the screen. And so it should automatically be on that graph, and you should just be able to hit enter. Then it will ask you what the second curve is, and it should automatically change to displaying y2 at the top of your screen, and you hit enter, and then it's going to ask you for a guess, and you just have to go move your cursor over kind of nearby that intersection point and hit enter, and then it should pull up the solution, which, one second, I'll pull that up on my screen. Okay, here is the calculator screen. So again, you do second, calculate, and you're looking for the intersection. That's the fifth choice. First curve should display the equation for the first side of that equation, that first y1. If you hit enter, it should automatically switch to y2, hit enter, and then you just need to go over close to that intersection. Let's see where my cursor is. There it is. And get close by and do the guess, and then it should tell you what that intersection point is. So it's telling me here at the bottom of the screen 3.298 for the x value, 2.740 for the y value. Now we only really care about that x value because we were trying to solve an equation for x. So we would say that our answer is that 3.298. It's not closing. Sorry, there we go. So we would say 3.298 would be our x value. Now again, we only pick the x because our equation asked us to solve for x. Okay, so here's our next problem. Solve for x. I want to know what the ratio of the area of square A to square B is, and then I want to know what the value of x would make that ratio 5 to 2. So the area of square B, or sorry, square A, let's start with square A. To find the area, you would just multiply those two dimensions, the length and the width. So the area of square A, if we multiply that out, is x squared plus, there's a 2x and another 2x for a total of 4x, and the 2 times 2 is 4. And we're going to write our ratio as a fraction. The area of square b, hopefully you can see the area there is x squared. So this fraction is the ratio of square a to square b. Now this says if that ratio is 5 to 2, what is the value of x? So it's written here with a colon. That's another way of writing a ratio. We're going to write it in fraction form. 5 to 2. So we want to solve this equation. Well, we could solve this by graphing it, and we end up with this graph here. So the ratio is this graph. And then the 5 over 2 is this straight line. So we're wondering when those two things are equal. Well, it looks on my graph like we have two possible intersection points, but in the context of this problem, one of them doesn't make sense, and that is the negative one. So we don't need to figure out what value that one has. It doesn't matter. X is not going to be a negative number. It doesn't make sense for this little square here to have a negative side value. So we're actually just looking for this one. I'm going to go ahead and pull up my calculator on my screen and show you again how to find that intersection point. Hold on. Okay, so here's the equations graphed. And again, we're just looking for this intersection point here. So if we have the calculator calculate that, we do second trace. So we're looking for this function calculate here. And it's going to be the fifth choice. It asks us what the first curve is, and you can see it's displaying y1 there. That's great. So we hit enter. It asks us what the second curve is. Sorry, it's being really slow. Maybe I need to hit enter again. Did I fry my little calculator? It seems as if it's stuck. Let's see, hold on. Okay, sorry, that's user error. See how it doesn't have a y value displayed? Right now it's on the asymptote, so I just need to go over a teeny bit. Okay, so I'm on the first curve now. I hit enter. It jumps down to the second curve, and I hit enter. And now it asks us to guess at that intersection. So I'm going to go over here near to this intersection point. Now, one of the reasons it has you tell a guess is because there are two intersection points, and it wants to know which one you're interested in. We are only interested in that intersection on the right side. So I hit enter near that point, and it should calculate that intersection. Now again, in this problem, we were wondering what x value. We don't care about that y value at all. It's 5/2, just like we knew it would be, but we are interested in that x value, and it looks like our answer would be 3.44. Okay. So now we're going to work on solving algebraically. We're going to start with some really basic equations. So I want to find the values of y that make each statement true. Well, if 1 over y is equal to 1 over 5, what y value has to be the only true y value? I hope you can see that y would have to be 5. Without really doing any fancy equation work, 1/5 is only equal to 1/5. Well, what about this one? If I have y over 11 is equal to 8 over 11, y has to be 8. If the denominators down here are the same, the only way that those two fractions can be equal is if the numerators are also the same. And we're going to use that idea today to help us solve these equations. So this first one says solve for x. Well, we want to get a common denominator here. Now, sometimes people look at fractions like this and they say cross multiply, and I am not going to be doing cross multiplying today. is kind of a trick that a lot of people don't understand, and it can lead to a lot of issues. So I'm not going to be using that method. If it's a method you are familiar with, you're welcome to use it, but I will not be using that method. So when I look at this equation, I see that one of them has a denominator of x plus 2. The other one has a denominator of 3x plus 8. There's nothing I can factor or anything, so to get a common denominator, I'm going to go ahead and times this side by 3x plus 8 over 3x plus 8. And the other side is going to be times by x plus 2. And that will give us both sides of the equation with a common denominator of 3x plus 8 times x plus 2. Now I'm going to rewrite it, but that's not necessarily something that you would need to rewrite. Okay, so you can see that what we have now is a rational expression that has a common denominator. Well, the only way for those two fractions to be equal to each other is if their numerators are also the same. So we now know, whoops, that's an x. We now know that these two things have to be equal. 3 times 3x plus 8 has to equal 5 times x plus 2. So we can just go about solving that. So this would be a 9x plus 24, and this would be a 5x plus 10. And we solve that in the usual way. We could subtract 5x, and we could subtract 24. So what we're left with now is we have 4x over here, and that's equal to negative 14. We're solving for x, so our last step would be to divide by 4. X equals negative 14 over 4, which we could reduce to negative 7/2, or if you really wanted to, you could also put the decimal equivalent there. Whichever of those you like the best. I usually just leave my answer as negative 7/2. So that's the method we're going to be using to solve. So let's try another one of those. Solve for x. We have 6 over x plus 2 equals 12 over x minus 1. We're going to get a common denominator. It's going to be x plus 2 times x minus 1. So this side of the equation is going to get multiplied by x minus 1. This side of the equation is going to get multiplied by x plus 2. I'm not going to rewrite it this time. So right now we have a common denominator. Well, the only way for those two fractions to be equal to each other is if their numerators are also the same. So we know that 6 times x minus 1 has to equal 12 times x plus 2. If we distribute that, we have 6x minus 6, and we have 12x plus 24. So we can solve the equation by subtracting 6x, and I'm going to subtract 24. So that's gone. We have negative 30 is equal to 6x. So when we divide by 6 as our final step, we find that x is equal to negative 5. Okay, well, rational functions often have domain restrictions. When we graphed, we would say things like, the domain is all real numbers, but x can't equal 5, or something like that. This part of it is called a domain restriction. So the x values that cause problems in rational functions are the x values that cause dividing by 0. So we can't have the denominator be 0. On the graph, the domain restrictions look like vertical asymptotes, and they look like holes. With rational equations, we actually need to watch out for these as well. We need to check our answers to make sure they don't cause division by 0. So remember that the denominator is what gives us those problems on the graph. The denominator is what also gives us our restricted values in the equation. Sometimes they pose as solutions, but they are extraneous. So we've had extraneous solutions before with square roots. We also need to check for those with rational equations. So let's try to solve this problem. So we have x plus 5 over x plus 3 is equal to 2 over x plus 3. You can see that this equation right now already has a common denominator. So the only way for those two fractions to be equal is if their numerators are also equal. Well, if we solve this equation, we get x is equal to -3. Well, if we plug -3 into this equation, we get -3 plus 5 over -3 plus 3 is equal to 2 over -3 plus 3. Well, if we simplify that, we have this equation. 2 over 0 is equal to 2 over 0. But this quantity 2 over 0 is undefined. It doesn't work. The equation is just one giant error. So when you look at an equation, you can right away tell what your answer can't be. In this equation, our answer can't be equal to -3 because that would cause division by 0. So our solution does not work. We would say that this equation has no solution. Let's try another one that has an extraneous solution. So here's our equation, 6 minus 2x over x minus 3 equals 4 over x. So if we want to work on getting a common denominator, our common denominator is going to be x times x minus 3. Remember, those are two completely separate factors there. So we're going to times this side of the equation by x and this side of the equation by x minus 3. Well, we now have a common denominator. They're exactly the same. So we can go ahead and set those numerators equal to each other and solve this equation. Well, if we distribute this, we get 6x minus 2x squared. And over here, we get a 4x and a -12. This is an equation that has a power of 2, so that means we're going to be finding two potential solutions. So I'm going to add 2x squared to this side of the equation. Now the reason I'm adding it to the right side is because I don't like having a negative as my power, as my leading term. So I'm going to add that, and I'm going to subtract the 6x. So now what we have on this side of our equation is 0. We have 2x squared minus 2x, because we combine these two terms, and minus 12. Well, we could go ahead and factor a 2 out of that equation. It has a common factor of 2. So we now have 2 times x squared minus x minus 6. Okay, so we can factor this to get our two solutions. So here's what our equation looks like now. So we have a couple of potential answers here. We have 3 and we have -2. But if we look back at our original equation, you can see that we have two restricted values. We know that x can't equal 3 or 0. Again, that comes from these two factors in the denominator. Can't equal 3, can't equal 0. both those values would cause division by 0. So that means from our answers that we got, we have to throw out the 3. X can't equal 3. So we have one answer, x equals -2 is the only solution to this equation. So sometimes you'll have no solution like that last one. Sometimes only one of the potential solutions will be extraneous. Sometimes in an equation like this, both solutions work. You just have to try it out and see. Okay, so this is one I wanted you to see that having two solutions doesn't mean that one of them is extraneous. This one does just have two solutions. So we're going to solve it the same way we've been solving. We're going to get a common denominator. In this case, we have a denominator of 2x plus 1 and 4 minus x. So we'll times this by 4 minus x, top and bottom, just timesing by 1, and times this side of the equation by 2x plus 1. So we now have a common denominator, and the only way for those two fractions to be equal to each other is if the numerators are also the same. So this would be 4x minus x squared. This would be 10x plus 5. I don't like having a negative x squared, so I'm going to go ahead and add that over here. And now we have 0 equals x squared plus 6x plus 5. Well, to get our two potential solutions, we can go ahead and factor that. This one is x plus 5 times x plus 1. So our two solutions are -5 and -1. If we look back at our original equation, we have two excluded values. We know that x cannot equal, the first one would be, I'm looking at that factor of 2x plus 1, so that means -1/2 is causing us a problem. That's an excluded value. The other one would be if 4 minus x is equal to 0. So you can see that that means that if x equals 4, that would be a problem. So the two excluded values are here. That means that both of the solutions that we found are fine. So this would be our answer, x equals -5 and -1. Again, this is just us checking to make sure that we don't have an extraneous solution. Okay, let's get a common denominator again. One more of these solving for x problems. It looks like one of our fractions has a denominator of 4. The other one has a denominator of x plus 3. So that combination is going to be our common denominator. So we have 28 over 4 times x plus 3 is equal to x times x plus 3 over 4 times x plus 3. We now have a common denominator. So we can say that 28 is equal to, and I'm going to go ahead and distribute that, x squared plus 3x. Okay, we're going to have two potential solutions here that we'll check. So we're going to go ahead and subtract 28. So I have 0 equals x squared plus 3x minus 28. That one we can factor. It's an x plus 7 and an x minus 4. That's equal to 0. So our two potential solutions are -7 and 4. Now we just have to check to make sure neither of those are extraneous. So if we look at our original equation, you can see that what we know x can't equal is -3. So both of our solutions are fine. Both solutions are okay. Sometimes people like to just go ahead and write their excluded values at the very beginning, and then when they get to the end, they can just do a quick comparison. Okay, so sometimes people are like, why can't I just cross multiply? And this equation is a good example of that. If we cross multiplied this, we would get a really awful equation. But if we think about getting a common denominator, let's think about what this denominator has. it just has 2 factors of x minus 3. And this denominator is an x times an x minus 3. So you can see that they already have one factor in common. Our common denominator, it has to have 2 factors of x minus 3 because that first one does, but it also needs a factor of x. So this is going to be the common denominator. So the first one already has 2 factors of x minus 3. We need to times it by x. The second one has an x and it has one x minus 3. We need to times it by another x minus 3. So we now have a common denominator on both sides of our equation. So that means the numerators must be the same as well. So we have this equation. I'm going to go ahead and distribute the 3x. So that would be a 3x squared minus 9x. And that is, of course, still equal to 9x. So I'm going to subtract 9x to this side of the equation. So now we have 0 equals 3x squared minus 18x. So if we solve this or factor it, we would factor out a 3x. And that would leave in the first term x and in the second term minus 6. So we have two potential solutions, 0 and 6. Well, if we think back about our original equation, the two values that we can't have, x can't be 0 or 3. Again, 3 would cause this one to be 0, and the other one comes from this factor x. So we would have to throw that one out as an extraneous solution, and we would just have one solution, x equals 6. If you tried cross-multiplying on that, it would have been lots more complicated. It would have been a degree 3 equation, and it would be difficult to solve. Okay, so let's try this one. So thinking about what factors are in the denominator, remember x squared is just x times x. So if we're thinking about what our common denominator should be, we need a factor of negative 3 and an x, but since this one has 2 factors of x, we do need it to be negative 3x squared. Now I write those two x's separately just to help you see that there are 2 factors of x there, but in my equation I'm just going to use this negative 3x squared. So that first one already has both factors of x. We're going to times it by negative 3. The second one already has a negative 3 and already has one factor of x. I'm just going to times it by a second factor of x. We now have an equation that has a common denominator of negative 3x squared. That means negative 3 times 9 minus x has to equal 4x. So if we distribute that, we get negative 27 plus 3x, and that's equal to 4x. And we can continue to solve. Let's see, I'm going to subtract 3x here. So we have negative 27 is equal to x. Well, that looks like that would be our solution. Now, got to check for extraneous values. So if I'm looking at my denominator over here, negative 3x, the only issue would be if x is 0. So it looks like our equation has one solution of negative 27. Okay, we're going to look at a couple of little application problems. From 1995 through 2003, the annual sales of some entertainment software is modeled by this equation. Now, this part of it over here is just telling me that it just works for that little section of 8 years. And t in this equation is the number of years since 1995. So our first part says, in the year 2002, what were the sales? It's asking us to calculate the value of S. Well, we've got to figure out what T is in that case. Since T is the number of years since 1995, 2002 would be 7. Was that okay? I hope that's okay. So 1995 would be 0. 1996 would mean that t is 1. 1997 would mean t is 2, etc. So 2002 would be t equals 7. So basically it's just asking us to plug 7 into the equation. And as you're doing this, evaluating in your calculator, just like with graphing, you kind of need to be careful to make sure that your calculator is grouping both the numerator and the denominator. So if we calculate that, we have, whoops, 3220. Should get 7.5. And now remember that that's in billions of dollars. So $6.75 billion would be the annual sales. Okay, so the next part says, for which year were the total sales about 5.3 billion? So this one is giving us the S value. Now notice that that's less than the 6.75 that we just got, so it's got to be a little sooner than 2002. That gives us one clue about what the answer might look like. So we're going to put that in here. And solve for t. Well, we have a fraction here, so we're going to get a common denominator of 115 t squared plus 1,000. Okay, now that we have a common denominator, we can set those two things equal to each other. Let me get some space. Here we go. So we have 5.3 times 115 t squared plus 1,000 is equal to 848 t squared plus 3220. And again, because we have a common denominator here, we can set those numerators equal to each other. Let's distribute that. 5.3 times 115, 609.5 t squared, and 5.3 times 1,000 is 5,300. Well, if we're solving this, let's see, let's get the t squareds together. And I'm going to move the 3,200 to the other side. We're going to use the square root method of solving this. So that's gone. 5,300 minus 3,220 is 2,080. And 848 t squared subtract 609.5 t squared is 238.5 t squared. So if we divide by 238.5, we have 8.72 is equal to t squared, and our final step would be to take the square root of both sides of our equation, which tells us that, sorry, gotta reset, 2.95 equals t. So remember that t is the years since 1995. So this is about 3 years after 1995, so this would be around 1998. Maybe right that December, right before 1998. Okay, one more. Bethany scores 10 free throws out of 18 tries. What is her current free throw average? Well, she's just gotten 10 out of 18. And so that means she's sitting around 56%. So this says she would really like to have improved her free throw average by 10%. She's going to keep shooting. So at this point, if she kept shooting, how many consecutive free throws would she need to make in order to improve her average by 10%? Well, if she keeps shooting, she's going to make, let's see. Right now she's already taken 18 shots. She's going to keep shooting a few more shots. So that her new total is going to be 18 plus X. We don't know how many more shots she's going to take. Well, so far she's made 10. I want to know how many more she has to make so that her average is 10% higher. So 66%. And I'm going to write that as a fraction, just because you could write it as a decimal if you want, but I just think it's easier to write it as a fraction. You could put 0.66 here. So the setup here is that she has already shot 10. She's going to keep shooting X more. She wants to know how many more she has to make so that her average, so we're going to divide by her total for the day, 18 plus X. It's a little tricky to set that up. So we're going to go ahead and get a common denominator. So I'm going to times this side of the equation by 100. I'm going to times this side of the equation by 18 plus X. So now I have a common denominator. And so that means the numerators have to be equal to each other. This is 1,000 plus 100x. That's going to be equal to 66 times 18 is 1188 plus 66x. So we can keep solving this to get the x by itself. I'm going to subtract, whoa, that was weird, sorry. Subtract 66x and subtract 1000. So we end up with 34x equal to 188. And when we divide by 34, we find that x is about 5.53. So that means if she wants to bring her free throw percent up at least 10%, she will have to make the next 6 shots. Now, if she made the next 6 shots, that means she would make 16 out of a total of 18 plus 6 is 24, which makes her percent 66.7%. So that would give her 10% more than she was currently at. So she needs to make her next 6 shots. Okay, so that's it for solving. Remember, as you're doing your homework, this unit is a challenging unit. If you have questions, please come in and get some help from your teacher before school, after school, at lunch, depending on your teacher's schedule, so that you can be ready for your test that's coming up in a week and a half or so. Thank you.